Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's video I am going to explore four practical examples based on binomial distribution. These will help you understand how to model real world situations where there is a fixed number of independent trials, each with the same probability of success. So, without further delay, let's get started. So, we begin with an example, but before that, we will understand what is the binomial distribution. So, basically, a random variable is said to follow binomial distribution with two parameters n and p if it is assumes only finite number of non-negative integers and its probability mass function is given by p x is equal to x, that is number of successes, and x p raise x q raise n minus x, where n is the number of independent trials, x is the number of successes in n trials, p the probability of success in each trial, so that is a constant, and q is 1 minus p, that is the probability of failure in each trial. So this distribution we will apply to solve all four problems. So let us see the first example. So the chances of catching cold by workers working in the ice factory during winter are 25%. So what is the probability that out of 5 workers 4 or more will catch cold? So let us see. So let's here catching cold be the success. Then that is P is equal to 25% at 0.5 and Q would be 1 minus P. So that is 0.75. Now here n is 5. So we will use binomial distribution, and here 5x, here P, here Q, and the question given that x is greater than or equal to 4. How? Because what is the probability that out of 5 workers 4 or more will catch cold? So here this is the value of x. So x is greater than or equal to 4. That means x is equal to 4 or 5. So for this one, these two values, we will calculate probabilities and we will add them. So here we will compute for x is equal to 4, that will be 0.014650, and thereafter for x is equal to 5, for x is equal to 5 we will have this one and we will add and we will get the final answer. So the probability that out of 5 workers or 4 will catch cold is 0.015627. Let us see another example. That is the sum of two binomial random variables. So let x and y be two independent random variables, so that x is following binomial distribution having number of trials are 4 and probability is 0.7. Another is the number of trials are 3 and 0.7 is the probability. That means n is 4, 0.7 is p, n that is p, and we have to find sum of x and y is less than or equal to 1. So here we will follow, or we will use, suppose that x is following binomial distribution having n1 and p. Probability must be same. Y that is n2 p. So x plus y will follow binomial distribution. Let me erase all the expression, write in clear. So here I am writing, if x is following binomial distribution where n1 and p, and y is following n2 here p. So x plus y will follow binomial distribution having parameter n1 plus n2 and p. So p should be the same, otherwise this law will not hold. So let's see further. So what will happen? Basically it is asking for required probability x plus y is less than 1. So p z is equal to 0 or plus p z is equal to where z is x plus y. So z is equal to 0, that you will put the value of x 0, so we will get this value, and for z is equal to 1 we will get this one 0.0035, and the final answer you will add both of them, that would be equal to 0.0037908. Let us see the third example. The probability of a man hitting a target is 1 upon 4. He fires 5 times. What is the probability of hitting the target at least twice? So let us see that. Here let hitting the target be a success. So P we have got 1 upon 4 and Q would be 3 upon 4. Thereafter n is 5, so using binomial distribution, so that would be 5 x 1 upon 4 raise x 3 upon 4 raise x. We have got this distribution, and the required probability, that would be, that means x is greater than or equal to 0, and that would be equal to 1 minus px is equal to 0 plus px is equal to 1. So that is the probability of x is less than or equal to 0, and if you subtract it from from 1, so it would be greater than or equal to 0, that probability. So that trick is used here, and in previous videos I have explained, so you can watch that videos. Now put the value of x 0, so 243 upon 1024 and 1 4.400 5 upon 1024. So we will subtract from 1. After adding them, we will get 47 upon 128. That would be the final answer. Let us see the fourth one. A policeman fires 6 bullets on a dacoit. The probability that the dacoit will be killed by a bullet is 0.6. What is the probability that the dacoit is still alive? So let us see. Let us find out n, p, and finally we will solve it for x. That would be the answer. So let the event a bullet kills the dacoit be considered a success. So probability of success p, that is equal to 0.6. P we have got. Q, that we will subtract p from 1, we will get q, so 0.4. number of independent trials, that means n, so that is 6, and we will plug it in the binomial distribution, so we will get this expression. Thereafter, the cat is still alive, so that means x is equal to 0, that uh, a bullet does not kill a dacoit, x is equal to 0 mean. So here x is equal to 0, we have to find the probability where x is 0. Dacoit is still alive, p is equal to p x 0, so we will plug the value, and that would be 0.001. Final answer, dacoit is still alive, 0.0041. So hope you understood all 4 examples, and using these examples you have understood how to apply binomial distribution for solving real life problems. So hope you understood, and for more resources like statistics, data science, machine learning, AI, robotics, you can visit my website www.postnetwork.co, YouTube channel you can visit, Facebook page PostNetwork Academy, LinkedIn page, and you can also find GitHub page related to AI, data science and software making. So hope you will support me, that will encourage me to make more videos on rigorous concept of data science, machine learning, robotics, computer science. So hope you have understood and you will support me. Thanks for watching the video.